conversations in 3 and 2, and those conversations in 1. Thank you. All right, we're taking notes. You've dated your paper, 9/12, and we're starting, this is functions. We're gonna provide ourselves with some vocab, some review, and then we can get into some deeper stuff once we really understand that foundation, those basics. So,
you get to use the function machine?
ooh, yeah, let's bring out the function machine. So, first, let's get a definition down. So, we're gonna say each element of A, big A is the name of a set. Each element of A corresponds exactly to one element in B, big B, name of the set. Parentheses, italicized x comma y, parentheses, are our ordered pairs. Thanks for writing these down in your notes silently and urgently. Let's draw an example of a function, or of a set, which will be a function. So here's set A, and here is set B. And in there I'm going to have my x1, x2, and x3. Over here I'm going to have a y1, y2. Great job taking notes. All right, so my first x, I'm going to have matching up with my first y. So this is like putting the x1 into the function machine and you get out the y1. Now x2, different number, right? I'm putting that into the function machine. I'm also going to get y1. That's okay. We can get the same number out of the function machine after putting in a different number.
Wait a minute. Okay.
And let's put in a third, a different x is, let's say, giving us a different y. What does this look like with that cool function machine? Let's draw.
Okay.
Well, we're running out of space. I'm going to do it over here. Alright, you guys can draw yourselves a little funky function machine. Give yourself some space to put things in. And what comes out, give yourself some space for the things that are going to come out of it.
Oh, I messed that up.
It's okay. Give ourselves a fancy F for a function. That is a function machine. Okay. Our first x1, let's say our x1 going in is a 1, and we get out a 4. My second x going in is a 2, and we also get out a 4. My third x going in is a 5, and I get out an 8. Okay. Is this a function?
I don't know.
Yeah. Yeah, you're allowed to get the same, you're allowed to have the number repeat on the way out, okay? So quick example of not a function. Not a function would be your x1 has 2 different y answers. So this is not a function, this is not going to work. If I put in a 1, I have to get out a 4 every single time. I can't put a 1 into this function machine and have it come out as a 3 one time and come out as a 4 another time. That can't happen. It will not be a function. So if this is a 3 and this one's a 4, that would mean that I have two different ordered pairs. I put it in a 1 once, I get a 3. I put in a 1 another time and get a 4. Those are two different ordered pairs. It is not a function. You cannot have different y's matching the same x. Okay? So it's not a function. Questions on that? Copy down these notes. I'm going to erase it in 10 seconds. Okay, if you don't have these notes, silently get them off of a partner this time. That one. Okay. So quick review. Independent. What's our independent variable? I can't spell.
That's
Independent.
I don't remember.
It can
Here's your choices: X or Y is your independent.
X.
X, you got it. Good thing we're reviewing. Dependent. What depends on the X?
The Y.
The Y. Go ahead and give yourself that little reminder. Dependent is going to be Y. So when we're talking about domain and range, each one corresponds to either the X or the Y. Who recalls what the domain corresponds to?
X.
The X. So it's going to be the set of X variables. Your domain, set of X variables. Brave soul, have a guess what the range definition will be?
The set of y variables.
Thank you, Seamus. Write it on your paper. It's going on the board.
Where can we go?
I can't imagine I can do that.
All right, copy this down. Anything I write, you should be writing too. Okay, next up, we're going to talk about increasing in a function. All right, so we're writing down increasing. So increasing is kind of the vocab term, right? Range and domain, independent, dependent variables, those are our vocab. So increasing is the vocab, but I'm adding in a function to clarify. So increasing in a function, and what our definition for that is going to be, it's intervals in the function, or intervals of the function. Interval or intervals, it could be one or it could be plural. So intervals of the function, I'm going to abbreviate the function with the fancy F with the X in front of it. The function when X is increasing.
Oh, we have to graph this.
Oh yeah.
Yeah.
Well, first, you're just going to identify it on a graph, but later you'll graph it.
Line graph or
No, it's
Coordinate, Cartesian plane, X, Y, coordinate grid. So increasing in a function, definition, intervals of the function, f of x, when x is increasing. Copy it down. Okay. Next is going to be, Liam, do you have a question?
Nope.
Okay. Decreasing in a function. I want you to try and write the definition on your paper. Try and write this definition on your paper. Hint, you can use this definition, and only one thing will be changed. Okay. We'll talk about it when we're done. Okay, so right now the conversation's just math. We do have a quick question. It's just a quick whisper about math. Otherwise, we shouldn't be off topic. What do you guys got? Decreasing in a function, it's what?
Intervals of the function when x is decreasing.
You got it. Thank you, Liam.
Yep.
It's on the board if you need that. Add it to your notes.
And when is it
Intervals of f of x when x is decreasing. Nice. I'm going to erase these. Make sure you get the notes. Take 10 seconds. If you need these still at this time, go ahead and silently get the notes from up here. I guess I can leave the last one for now. Okay. Next, maxima. Maxima. Max, I-M-A, maxima. Your maxima, and we can use, it's like, you know, if your name is William, but we call you Will, right? It's maxima, but we can call it max. So this is going to be largest
Oh my god, that is a unit.
I agree.
value of your function. Largest value of your function, f of x. Should specify, actually, largest y value. Yeah, it would be a largest y value, like vertically. Okay. Did we do anything with maximum today, maybe in art? Does anyone remember?
We did.
What was that all about?
Maximum
It's like the highest point of our line, our little line.
Yeah, we had kind of like a curvature. It was kind of like a person's face. You guys remember that?
Yeah.
So maybe that's a profile of a face. So this would be a maxima point. This would be a max point. Max, max, max. We had 5 maximum points today. Okay? So connection to art there. Okay, next is minimum. Minima, it's on the board. You can call it min. That is fine. Go ahead and write that in your notes. Someone have a guess on the definition for minima?
Smallest value of f of x.
You got it. Thanks, Liam. Write it in your notes. Smallest will clarify y value. Smallest y value of the function f of x. You could write the word function too. I'm just abbreviating, making things shorter. Next vocab, end behavior. We're going to draw all these out in a visual example next. But end behavior is your next vocab. Thanks for getting that down into your notes.
I miss, I don't, I'm joking.
This is what happens. This is what happens to the function. So I'm going to abbreviate f of x. What happens to f of x as x is approaching infinity, positive infinity, and as x is approaching negative infinity.
How do you approach infinity?
You can't ever reach it.
You get
Yeah,
bigger.
you can
All you
only
can do is
approach
approach it.
Yeah.
Really good question.
Approaching the end of it? Whatever.
Well, no,
That
let's
makes
answer.
sense.
It goes on and on and on forever. If the line is going forever and ever and ever,
I'm okay now. I
how
asked
can you
a
ever reach
stupid
it?
Question. That was my bad.
I'm glad you've resolved it.
Yep.
Okay.
I know.
What happens to the function as x approaches infinity and x approaches negative infinity? One last vocab, and we're going to sketch. Intercepts. Intercepts. Intercepts are going to be the points. Point or points. I mean, it might be one. It's usually more than one. Points on. Let's see. Points where the graph crosses the x. Where the function. Sorry. Points on the intercepts. So points on x and y axes, or the intercepts, right? X and y axes where the function intersects it. Points on x and y axes where the function intersects it, or f of x intersects.
I just realized something.
Go ahead and copy those down in your notes. I'm going to erase this in 10 seconds.
Is it on the
You don't have a book.
okay. There's two left. You have groups.
Yes, it
There's two PreCalc.
Yes.
Oh, right.
Okay, that last definition, if you still need it, please silently get that last definition from up here. Next, you're going to need at least half of a paper. You may even want to flip to a fresh page of paper. You want a large space. I'd say at least half. It's helpful if it's, near the vocab, but it doesn't matter if you need to go to a new page. So we're going to do a really big coordinate grid. We're going to be drawing in all 4 quadrants of that coordinate grid. So draw yourself a really big,
like
quadrant. Like at least half the page.
Yeah.
It needs to fully fill at least half a page. Like end to end, left to right, all the way across. Or just center, if you're on a fresh sheet of paper, just center it and use the whole page.
Oh, that is not even close to the middle.
Our intercepts, our x and y axes go on and on forever and ever in all directions. We add arrows. You may label y the vertical one, x the horizontal one.
But we don't go like up to upper 10.
You do not have to number them today.
You know what always bothered me?
Okay. We're going to draw one function and label every single part of it with our brand new vocab. Your function, I'm going to, let's see. It may be helpful to give yourself markers. Let's start with that. Give one like a third or like a quarter of the way up on the positive of the y-axis. On the negatives of the x, kind of about that wide apart. And then a little farther down, and one pretty close to the end of your x over here, and one way down here.
Does it matter what points there?
No, just kind of estimate. We're not using real numbers. We're not going to use any real numbers. All right, and we're going to draw a shape.
Oh, it's exponential growth. No,
So using your, what kind of line would this be in art?
A curve?
Yes, which is an example of
a line.
Organic.
organic. Nice job.
I think something exponentially grow.
I think it's not for you to
Oh yeah, we have another point up here. Maximum.
I'm gonna unpower.
Okay. Go ahead and sketch. I'm going to come around and take a look and guide you if you need. Try and do a rough sketch that matches. Yeah, this is really helpful if you guys have your notes too.
Okay.
Yeah, we'll use this for sure. Nice. So this peak is a little, you have that as a max. The max isn't on the axis, it's a little to the right of the axis.
I didn't see that.
I added that out later, sorry, that was missing.
Attaboy, Hampton. Give him a big arrow quick.
Okay. I did add this dot a little bit later. Some of us may not have copied that dot, but your peak, your max shouldn't be on the axes. It should be a little to the right. So, FYI.
Well, it's a little to the right. We're just adding a dot there.
All right, let's start with intercepts. Intercepts, we already know that word. Does someone recall or look back in your notes? What does intercept mean?
It's where something crosses something.
It's where the
Can you use more vocab?
It's the point on the x and y axis where the function intersects.
All right, let's label every time we see that happen. I'm going to abbreviate. So I'm going to do x dash int when it crosses the x-intercept, int intercept. Label.
There's quite a few more x intercepts.
Yeah, there's only one y-interception, so we all know.
one y-intercept. In this example, we might have more in other examples. Here's a fun question, tricky question. What if this did have two y-intercepts? What if there's another y-intercept somewhere? Ah, nice. Someone's remembering their algebra 2. You guys must have had a good algebra 2 teacher.
Advanced algebra.
Okay. Or advanced algebra.
Oh, you mean algebra 2?
Okay. Alright guys, great sketches. Let's bring it back up here. We're going to talk about end behavior a little bit later, but let's just mark where the end behavior occurs, and it's truly just at the end. So end behavior would be here and here where the arrows of your function occur. So end behavior, 2 of them. Behavior. And each end behavior is going to be different because they're approaching different things. This one is approaching what?
Negative infinity.
Yeah, you got it. So as x approaches negative infinity, we can label that for ourselves. To the right, as x approaches what?
Regular infinity.
Regular or?
Positive infinity.
You got it. Good correction. Okay. Next, I don't think we made a dot here, but you can make a dot here, and we're going to call it a minimum.
But the minimum is.
There's
the
another
minimum that
Ah, good point. We have 2 minimums,
yes.
and one will be called the global minimum. So when we come over to this one, we can call this one the global minimum. What does global mean, and what might it mean in our class?
Global is like encompassing the whole world.
Everything. So out of the whole function, what's the biggest minimum?
The right one.
Therefore, we call this a global minimum. You guys are so smart. Now, maximum. Take a look at your graph of the board. We have 3 areas where we're getting into some higher y's. Like, those are high y's. This is a high y. Here's some high y's. Do I have 3 maximums?
Well, I mean, is it a maximum if it's just a line that keeps going?
Ah, no, it is not. Great question. So we only have 1 maximum, and it's occurring here. Only 1 max in this particular function. We could have some more kind of hills. We could have another max, but not in this example. All right, all of our mins and maxes, great. Yes?
That will be the global max, or not?
You could, yeah, you could say that. We only have 1, so, but yes, you could say that, yes. Next, we're gonna do a dotted line. If you have a different color, it might help your notes look less messy, or you could just continue with the same color and do a dotted line.
That's the move.
So next, all right guys, let's bring it back. Thanks. Thank you. We're going to create a vertical line every time you see a minimum or a maximum. Vertical line dotted anytime you see a minimum or a maximum. That's going to go the whole span of your Cartesian plane. Coordinate grid, Cartesian plane, same thing. X, Y, plane, all the same.
What a terrific show.
Okay. We're almost done. We got to label one more thing. You guys are doing great.
Oh, man.
You know what else is a good show?
What?
The rifle. Chuck.
I disagree strongly. Are these the kind of lines that should have arrows on the end of them?
No, well,
Oh, shoot.
oh, they could. They're kind of just marking a region for us, but they do technically go on and on forever. So you could add arrows.
They don't need to, is what you're saying. They don't need to have arrows.
Yeah, we're just kind of labeling regions of our graph. All right, we read a book left to right, correct? We read a book left to right, correct? Yeah. And when we look at a function, we often read them from, as far as the x's, we look at the x's, and we read the x's from left to right.
Yes.
Okay? And so if I were reading this, I would follow the function path from left to right. Okay? So keeping that left to right in mind, we can now label what is increasing and what is decreasing. So starting here, what am I doing, increasing or decreasing if I look at it left to right? Decreasing. So we're going to call this an interval where it's decreasing. So decreasing interval. Decreasing interval is only talking about the x's. It's the x from whatever x this is, you know, -10 to -7, whatever that x is. This is a region, and this is a region or an interval where we're decreasing. Oh, sorry, actually, all the way over to here. Sorry, all the way over to there. This is all a decreasing x region. Liam, is that math related?
Not really.
All right,
Sorry.
let's bring it back up here. We're almost done. Let's keep it going. If I'm following, continuing left to right from this region up to my minimum, up to my maximum, am I increasing or decreasing?
You're increasing.
Increasing. So this is an increasing interval. Label your notes. Okay. Nice job. It doesn't stop here, right? That increasing interval is going all the way over to this blue, my dotted line. Okay, now we're continuing reading left to right. From this maximum down to this minimum, am I increasing or decreasing?
Looks like a
I think you're decreasing.
Decreasing.
Decreases.
Wait, so those lines connect to every intersection point?
So we created regions based off of the minimums and maximums.
Oh, okay.
And now we're labeling our dotted line regions.
Right, okay. Yeah.
Okay? And last one, what do we think from the minimum going up to infinity? Increasing interval. Go ahead and add it to your notes. Double check yours. Looks like the board. Add anything at this time that you need to add. We are Thursday, 1:30, 20 minutes. Okay. Are you guys feeling good? Do you want to? Can you do a little bit more notes? On a roll with notes? Okay. So flip over. We're gonna be. This is a new. You probably want a new page for this with a new title. This will be on interval and set notations. I'm going to erase this. If you still need this graph, you're going to silently get it from a neighbor. If you want to divide your new page into 3 vertical intervals, that will be helpful. The whole thing? We're gonna make 3 columns in our notes.
Generally,
The middle one is very skinny, and then the one on the left will be slightly bigger. All right, I'll write the first one. You'll figure it out, Mary friend. All right, so we're gonna do 3 things. We're gonna do a small graph, and then we're gonna write what it is in interval notation. It's like a number line. We're graphing on a number line, so it's okay. It'll be shorter. Notation. And then set notation. And spread this out across your whole page. So these are the 3 titles spread across the page. So we're going to come down and make a list. And we'll have the graph, the interval notation of that graph, and then the set notation of that graph. We'll go through 5 examples this way. So, like that.
Shaves, you stuff to improvise. That's
You got a whole page. Use the new
The absence of evidence is not the evidence of absence.
Give yourself.
It doesn't make any sense.
No, stop saying.
Okay, guys, bring it back. We're gonna get through these. Thank you. So give yourself a short number line. All you have to do is put 2 solid dots on it, label them A and B. And I'm gonna write or. We're gonna give ourselves the alternative graph to this, which instead of a closed dot, we can also do what?
An open one.
dot.
Sorry,
Or brackets.
confusing question. What would be an equivalent way to graph the same thing with a different symbol?
Square brackets.
Yeah, square bracket.
So
So we're gonna provide ourselves both examples because sometimes, you know, standardized tests like SAT, ACT, we'll just pick one. And you need to know both ways. You need to be able to recognize both ways that this very same thing can be represented. So these are both a closed interval example. Closed interval. In interval notation, it's that closed bracket, A comma B, closed bracket. And in set notation, we're using the set bracket, X for A less than or equal to X, less than or equal to B, close your set bracket. So as your first one, we're gonna do 5.
Oh, what?
Look, I can tell we did that.
Big job. I've got an entire page of paper. Look at me.
Okay, next is open interval. Give yourself a quick graph. Open, open, shade below, between. What's an equivalent way, we'll call them A and B again. What's an equivalent way to graph this on a number line representing the same thing?
Parentheses.
Parentheses, awesome. Any kind of shading. You can do squiggle shading, you can do straight line like a bar shading, doesn't matter. What would our interval notation for this look like?
I don't know, probably parentheses on A and B.
You got it.
Come on.
Set notation for all X.
I don't know, probably X. Actually, it's probably the same as the one before, just without the or equal to bits of the less.
You got it.
Yeah.
A is going to be less than X, is going to be less than B, close set notation bracket.
Wow,
Okay. We've got 3 more. Half, open interval. Now that you've mastered, you know there's 2 different ways to write this. You guys know that. We're just going to do it once now for the remaining examples.
Cool.
So, half open interval, let's have open A and closed B, shade between. Want to hear from someone new, what would our interval notation look like?
bracket A, comma B, parentheses.
I disagree with Hammond. I think it would be parenthesis A, comma.
Okay, I wrote it the opposite way.
That's okay, we're all learning. It's correct on the board. Parenthesis A, comma B, bracket. We're not laughing, we're all just learning.
Alright.
Okay, X, for all X's, our A is going to be less than X, and X is less than or equal to B, close bracket.
Did you get that, Ham?
Yes, I did. Faster than you did.
All right, let's be polite. Are we good on the first one? I'm going to erase that for space.
I think so.
Okay. You still need the first. Look on to appear.
I do. Nobody cares. I wasn't.
We got 2 more. Closed.
We've been talking to
Infinite interval. Closed infinite interval, and this is just a B going towards infinity. Give yourself a quick number line, B towards infinity. In interval notation, any guesses?
B and B are the guess.
B, comma, infinity with, I don't know, with a bracket around B and then a parenthesis around infinity.
Yes. Will there ever be a bracket around infinity?
No,
Nice.
it doesn't
Why?
make any sense.
Nothing.
Beautiful.
What if you push the
You can never reach infinity. You can only approach it.
Yeah, sure.
Infinity.
Set notation for all X, our B is going to be less than or equal to X, close bracket. Last one,
I watched Gran Torino.
closed, open. open infinite interval. Let's get practice going the other way. So we're going to have an open A going to infinity to the left. Okay, so infinity is now on the left. You guys told me it's always a parenthesis. And then on the right we have A. We cannot equal A, so we have a parenthesis there. Set notation for all x.
Would it be negative infinity because it's going to the left?
Oh, yeah. Oh, good call. Thank you, Hammond. Negative infinity. Good call.
Add the other half.
Add that negative if you didn't have it as I read it.
Underline, that's just shitty part of it.
For all x, x is less than a.
Because it goes-
Check your notes to make sure you have all of that in your